Okay, so here's where we are going to put all of the pieces of the puzzle together and create our sketch. But before we do, I'm going to go ahead and grab all of our work from our previous videos and put it all on this slide so we can see everything together. The first step was factoring, and I already have that. I factored right here. The next step were holes. There's no holes. So we'll go ahead and get an example from that in a few minutes. All right, the next one, which I usually label as a V, that's our vertical asymptotes. And remember, our vertical asymptotes were x equals a negative 3.5. Whoops. There we go. And remember that negative 3.5 had behavior that was opposite. But that's not the only vertical asymptote we had. We also had x equals 1, and that was the same behavior. The next thing that we had was the horizontal asymptote, and the horizontal asymptote was just the y-axis, which is y equals 0. Then we had our zeros, and for our zeros we had negative 1, 0 with straight behavior, and we also had negative 3, 0 with straight behavior. Then we have our y-intercept. Oh, so important, and oh, so important to check your calculation. And the y-intercept was 0, 3/7. And then after that, we're going to graph it, and then we're going to state our domain and range in interval notation. So here we go. The first thing we're going to do is we are going to kind of sketch out some tick marks. Usually when you go and sketch a rational function on paper, we usually give you a blank x and y axis because, again, it's a sketch, and you just kind of draw your tick marks accordingly to make sure you have everything fit. Okay, so we're going to go ahead and start with our vertical asymptotes, which again are going to be vertical lines, kind of behave like a brick wall. They're not really part of our graph. They're just part of the puzzle that shapes our graph. So it's going to be a dotted line, and it's going to be something that, again, we just use to determine the shape of the graph and also the end behavior. So this right here is going to be my vertical asymptote, which is at negative 3.5. I also have a vertical asymptote at a positive 1. So I'm going to go ahead and put this here, scoot it over a little bit so it's right on the 1. But remember that we also need to label the behavior of the graph. So for our negative 3.5, this was opposite behavior. Notice I am labeling everything, and if you want full credit on your tests and your quizzes and your homework, you have to label your vertical asymptotes in addition to the behavior. And this is x equals 1, and x equals 1 has same behavior. The next thing that I'd like to show you is your horizontal asymptote. And remember, the horizontal asymptote is really just the x-axis or the y-axis. So usually we just kind of bold this out and label it horizontal asymptote because you want to get full credit for graphing your rational functions. So let's just kind of see what we've done so far here. We have definitely factored, so that's done. There's no holes, so we don't have to worry about that. And then we just did our vertical asymptote, so we just did our horizontal asymptote. So here we are where we need to go and graph our zeros. All right, so we have a 0 at -1, and it has straight behavior. You've got to label that to get full credit. We also have another 0 at the -3. It also has straight behavior. And then lastly, the driver of the graph is the y-intercept. So this y-intercept is at 0.375. And 3/7 is almost a half. And remember, we're just sketching. So my y-intercept is, approximately right there. I know it's above the y-axis because 3/7 is positive. Okay, so we are ready to graph. Always focus on the graph where the where the y-intercept is. If you notice, our vertical asymptotes have broken up our graph into kind of 3 sections. I have a section right here. I have a middle section in between the asymptotes. And then I have my last section over here on the right-hand side. What we're going to do is we're going to focus on the middle section right here. And the reason why I'm focusing on the middle section is because that's where my y-intercept is. And my y-intercept is the driver of the graph. So here we go. If you focus on where this y-intercept is right here, notice that it is above the x-axis, which means if I connect this to the x-intercept, it's going to look like this right here. That starts everything. Notice that there is not an x-intercept over here. So if there's not an x-intercept over there, remember an x-intercept's like a door. Then that means that this graph has to be up here. And remember, your graph wants to hug the brick wall, but it's never going to cross it. Your graphs are going to approach and get closer and closer to your vertical asymptotes, but they're never going to get there. So this graph is going to look something like this. So let's go back and focus where we kind of left off, which was right here. Remember, your x-intercepts are like doors. So if this was a doorway and I passed through, notice I have another doorway over just a little bit to the left. So if I go down here, then I have to go back up and cross the door to go to the other side. So my graph has to be up here somewhere. That's where it's going to continue. So if my x-intercepts are doorways, and if my graph is down here, then my graph has to swoop back up. It has to go through that door and go and hug my vertical asymptote on the other side. So here's the deal, and here's what I want to emphasize. Remember, this is a sketch. So if you happen to plug this into a graphing calculator and it looks a little different, that's okay. As long as you see a minimum down here, and as long as you see the graph going up on either side of the vertical asymptote, then you're probably doing right. So now that we have this middle section finished, that's the hard part. The rest is going to be a piece of cake. So now we're going to focus over here on our left-hand side of the graph, on the other side of this vertical asymptote, which is at -3.5. And this is also why we wrote that word right there. And remember, that word was opposite. So when you think about the word opposite, what's the opposite of up? It's got to be down. So instead of an up arrow, I'm going to hop over to the other side and draw a down arrow way over here, because that's where it goes down. So if it's up on this side and it has opposite behavior, you hop over and you draw a down arrow right here. So that's what we're going to do. So this graph, if it goes down, then it had to come up to go down here. Now, if you notice, we do not have any doorways. We don't have any x-intercepts right here. So the only thing that this graph can do is just go hug or approach the horizontal asymptote. So this is going to curve, and now it's going to hug the vertical asymptote. That is the correct way to draw a graph approaching the vertical asymptotes. This would be incorrect, and this would be points off, because that's just a curve. Look at all the distance between the graph and the actual horizontal asymptote. So be careful. Make sure you write it correctly where it does hug the vertical and the horizontal asymptotes. So we have 2 parts graphed. We have 1 part left, and the 1 part left is over here on this side of the graph. So again, we're going to look at the at the vertical asymptotes, and we're going to focus on this behavior right here, which is same. So find your arrow close to the vertical asymptote x equals 1. Here's the arrow right there. That arrow is pointing up. So if that arrow is pointing up, then the same behavior also has to be up. So we're going to hop the brick wall, go to the other side of the graph, and draw an up arrow. Remember, up is, above the graph, down is down below the x-axis. But we're not going to focus on that because this was same. So we're going to go back up here and draw an up arrow. Okay, so we have started our same behavior. So I'm going to graph it back down here. If you notice, I don't have any x-intercepts. I have no doorways. So all I can do is hug the vertical and the horizontal asymptotes. And that's it. That's how you graph it. We've got one more thing left to do, and what we have left to do is talk about domain and range. So let's go ahead and talk about domain and range. Your domain is always going to have boundaries if you have vertical asymptotes or if you have holes. So let's go ahead and talk about domain. If you look at this graph, it goes on forever and ever in the negative direction. So we can start out our domain with negative infinity. But you got a brick wall. You have a brick wall at the negative 3.5. So we've got to exclude negative 3.5. But you do have a graph in the middle, and it goes from negative 3.5 all the way to x equals 1. Which was your other vertical asymptote. And then, after you jump a positive 1, it goes on forever and ever and ever to positive infinity. Then you have your range. There are not any gaps in the range for your graph. What I'm going to do is I'm going to grab a line. Here's a line. And the reason why I have this line is because if you notice, if I slide this red bar all along up and down the graph, there's no holes. I've got something going down forever all the way up to something going up forever. Remember, we had our same behaviors over here. So it goes up forever over here. It goes down forever over there. So I know that my domain is going to be restricted, but my range is always going to be negative infinity to positive infinity.